Hello, good day everyone. In this video, we are going to apply the similarity theorems about triangle to solve problems as well as real life board problems wherein we can apply the concepts about the similarity of triangles. Okay, so let's have problem number 1. Triangle ACB is a right triangle. CD is the line segment CD is the altitude to the hypotenuse AB. If the measure of angle A equals 45 degrees and BC is equal to 5 square root of 2, find the area of triangle ABC. So in solving any problem, especially geometry problems, we are going to start with the figure. So we have here triangle ACB is a right triangle. So if you observe, when we write triangle ACB, it is the conventional way that when we write triangle ACB, we look at the middle variable, which is C. It means that the right angle should be at C. So we can have this right triangle. So look at my figure. Angle C is the right angle. So this triangle is a right triangle. Next, we have if the measure of angle A is equal to 45 degrees, meaning this angle measures 45 degrees, then it will also follow that the measure of angle B is also 45 degrees. Why? Because if angle C is a right angle, then it measures 90 degrees. And we know that in a triangle, the sum of the measure of the angles is equal to 180 degrees. So if this is 45, then angle B should be also 45, so that we can have a sum of 180 degrees. Now, looking at the right triangle, we can say that this triangle ACB is a special triangle, the isosceles right triangle, because we have the angles 45, 45, 90. Now, moving forward, BC is equal to 5 square root of 2. So this side measures 5 square root of 2. It will also follow that this side, AC, is equal to 5 square root of 2. So that's one of the property of this isosceles right triangle. Now, if we have AC and BC equal to 5 square root of 2, we are using this theorem that in a right triangle, in a 45, 45, 90 triangle, the length of the hypotenuse is equal to the length of a leg times square root of 2. And since the length of the leg is 5 square root of 2, we can say that the length of the hypotenuse, the length of AB, is equal to the length of the leg times the square root of 2. But we know that the square root of the length of the leg is equal to 5 square root of 2. So we can have 5 square root of 2 times the square root of 2. And of course, I know you know the answer. Square root of 2 times square root of 2 is equal to square root of 4. And square root of 4 is equal to 2. So we will have 5 times 2, and that is equal to 10. So the hypotenuse is equal to 10. It means that AB is equal to 10. Now moving on, we are asked about the area of triangle ABC or the triangle ACB. Now to find the area of any triangle, we use the formula area is equal to 1/2 times the base times the height, or 1/2 the product of the base and the height. So if you are going to look at our triangle, this 10 should be the base. So it means we need to find the height or the altitude from vertex C towards the hypotenuse. So that is CD. So according to the problem, CD is the altitude to the hypotenuse AB. So we can construct line segment CD, and that will be the altitude or the height. So by definition, when we say altitude, that is a line perpendicular from the vertex to the opposite side. So meaning line segment CD is perpendicular to AB. That's why we are forming a right angle. Earlier, we know that the measure of angle B is equal to 45 degrees. So again, if we consider this triangle on our right side, if this angle B measures 45 degrees, it will also follow that this angle BCD, is equal to 45 degrees. So again, we have a 45, 45, 90 triangle. So we can apply the theorem in order to find the length of this CD. So in this triangle, line segment CB becomes the hypotenuse because we have our right angle right here. So going back to the theorem, in a 45, 45, 90 triangle, the length of the hypotenuse is equal to the length of a leg times square root of 2. So we follow the formula, hypotenuse is equal to the leg times square root of 2. And since we know that the hypotenuse, this one, is equal to 5 square root of 2, so we substitute h by 5 square root of 2 and copy leg times square root of 2. Now, in order to solve for the length of the leg, we need to divide both sides by square root of 2 to eliminate this square root of 2. So that's properties of equality. So dividing both sides by square root of 2, of course, it will cancel with square root of 2. What will remain is we have the length of the leg is equal to 5. Therefore, CD is equal to 5. So this time, we already have what we needed. The length of the base, which is 10, and the altitude or the height, which is 5. Therefore, we can now solve for the area of this triangle. So area of a triangle is given by the formula 1/2 times base times height. Therefore, we have 1/2 times 10. So where did we get 10? 10 is the length of the base, the horizontal side. So that is the base, which is 10. And the height or the altitude is equal to 5. And then solving, 1/2 times 10 times 5, that is equal to 25. Therefore, the area of triangle ACB is 25 square units. That's it. Next problem. Triangle ABC is a right triangle. CD is the altitude to the hypotenuse AB. The measure of angle A equals 60 degrees and CD is equal to 6. Find the perimeter of triangle ABC. Again, in solving any geometry problems, start with the figure. And in this problem, the figure is given to be like this. So we have triangle ABC is a right triangle. Again, it should be triangle ACB because the right angle is at C. But let us just consider authors have different preference. Now, the measure of angle A is equal to 60 degrees and CD is equal to 6. So we are just going to verify if the figure is correct. Now, what is asked in the problem is you are going to find the perimeter of triangle ABC. So if you are going to recall, formula for the perimeter of a triangle is given to be this one. To find the perimeter of a triangle, just add the length of each side, the three sides. So you have the length of AB plus the length of BC plus the length of CA. So that's how you are going to find the perimeter of this triangle. The problem that we have now is those three sides that are mentioned, we do not have any data about their length. Therefore, we need to manipulate such that we can find the length of each side. And how to do that is to start with what is given. So again, measure of angle A is equal to 60 degrees. Now, CD is the altitude to the hypotenuse AB. Again, when we say altitude, it is a perpendicular line from vertex C to the opposite side. That's why uh, CD is perpendicular to AB. And then another given, we have CD is equal to 6. Now, we are going to focus with this triangle, the smaller triangle, triangle ADC, because we already have the given. Again, since this is an altitude, it means that CD is perpendicular to AB. It follows that this angle, angle CDA, this angle is a right angle. Now, if you are going to look at our triangle, the new triangle, the triangle on the left, we have a special right triangle. Why? Because if this is 60, then this angle should be equal to 30 degrees. Why? Again, the sum of the angles of a triangle is equal to 180 degrees. So we have a 30, 60, 90 triangle. And again, that is another type of special triangle. So from this given, we can start finding the length that we need to find. So if this is our 30, 60, 90 right triangle, side AD will be called the shorter leg because it is the side opposite the 30-degree angle. And then this side is the longer leg because it is opposite the 60-degree angle. And of course, obviously, CA is the hypotenuse because that is opposite the right angle. That is always the hypotenuse. Now, we start with this theorem. In a 30, 60, 90 triangle, the length of the longer leg is square root of 3 times the length of the shorter leg. Again, the length of the longer leg is square root of 3 times the length of the shorter leg. So going back to the figure, the length of the longer leg, or CD, that should be equal to the length of the shorter leg, or square root of 3. We start with square root of 3 times the length of the shorter leg, which is AD. So we have this formula from this theorem. CD is equal to square root of 3 times AD. But we know that CD is equal to 6 based on our given. So with this, we can find the length of AD. What we need to do is to divide both sides by square root of 3 so that what will remain on the right side is just AD, or the length of AD. So dividing both sides by square root of 3, of course, this will cancel. So that's it. And then we can have AD is equal to 6 square root of 3. And then to make it more beautiful, we can apply the symmetric property so that we can write it this way. AD is equal to 6 square root of 3. Now, in mathematics, if you can recall during your second quarter, one of the competency is rationalization of the radicands. It is not allowed to have a radical expression in the denominator. So what we can do is to rationalize, and how we do that, we multiply each term, the numerator and the denominator, by square root of 3. And that will yield 6 times square root of 3 is 6 square root of 3. square root of 3 times square root of 3, that is square root of 9. But we know that square root of 9 is equal to 3. And 6 divided by 3 is equal to 2. Therefore, AD is equal to 2 square root of 3. That's it. So we can have the length of the shorter leg is equal to 2 square root of 3. So at least we are moving forward. Next, we need to complete. We already have the length of the shorter leg. We also have the length of the longer leg. With these values, we can find the length of the hypotenuse by applying this theorem. In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg, meaning the length of AC is equal to 2 because we have twice. So 2 times the length of the shorter leg. The length of the shorter leg is 2 square root of 3. So that is 2 times 2 square root of 3. And 2 times 2 is equal to 4. That's why we have the length of AC, or the hypotenuse, is 4 square root of 3. And that is one of the length. That is the length of one of the sides that we are looking for. We have CA or AC. We can have the value of CA as 4 square root of 3. Meaning, we still need to find the length of AC as well as the length of AB. So how to do that? We need to consider the other triangle. Triangle CDB. So we started this earlier. We have this angle as 30 degrees, and at the very beginning, we know that the measure of angle C is equal to 90 degrees because it's a right triangle. Since this angle measures 30 degrees and they are complementary angles, meaning this angle should measure 60 degrees. And since we have a right angle, 60 plus 90, 150, so it will imply that the measure of this angle should be equal to 30 degrees so that we can have a sum of 180 degrees. So again, considering this triangle on our right side, we have again another special triangle, the 30, 60, 90 right triangle. So again, we can apply the theorems to find the length of the missing length of the sides, DB and CB. So first, let us know where is the shorter leg, the longer leg, and the hypotenuse. Of course, if this angle is the 30-degree angle, then it means that CD, opposite this angle, is the shorter leg. As well as, since CB is opposite the right angle, then it is the hypotenuse, and this side DB is the longer leg because it is opposite the 60-degree angle. So always do that so that you will not be confused because we are dealing with a lot of triangles. Going back to the theorem, in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. So the length of the hypotenuse, CB, is twice the length of the shorter leg, meaning the length of CB or BC is equal to 2 times 6, twice the length of the shorter leg, which is 6. And we know that BC is equal to 12 because 2 times 6 is equal to 12. So this time, we have another value that we are looking for, the length of CB or BC, which is equal to 12. So what we are lacking now is the length of AB, and that is not difficult. Apply the theorem again. The length of the longer leg is square root of 3 times the length of the shorter leg, meaning the length of DB is equal to, or BD is equal to 6 square root of 3. The length of the shorter leg times the square root of 3. So meaning we have the length of DB is equal to 6 square root of 3. And observe that if we add these two segments, AD and DB, that will constitute the length of AB. So 2 square root of 3 plus 6 square root of 3, that is equal to 8 square root of 3. So this time, we already have everything that we needed. So perimeter of triangle ABC is equal to 8 square root of 3 plus 12 plus 4 square root of 3. Of course, recalling our lesson about radicals, we can combine like terms. 8 square root of 3 or like radicals, similar radicals. 8 square root of 3 plus 4 square root of 3, that will be equal to 12 square root of 3 plus 12. And since this cannot be combined or simplified further, then this is our final answer. Therefore, the perimeter of triangle ABC is 12 square root of 3 plus 12. And that's it. Let us now move to problem number 3. In a 45-45-90 triangle, the length of the hypotenuse is 14. Find the length of the leg. This problem is a simple problem. So for this one, we are just going to apply the isosceles right triangle theorem, or the 45-45-90. It says that the length of the hypotenuse is equal to the length of a leg times square root of 2. So the length of hypotenuse, denoted by h, is equal to, so this is how you are going to translate verbal statements to mathematical equations. And then the length of a leg, so we're talking of a leg, so we can use the variable L, and then times square root of 2, so we multiply L by square root of 2. That's it. Based on the given, hypotenuse is equal to 14, so we can substitute h by 14, and that is equal to L times square root of 2. To solve for L, we need to divide both sides by square root of 2. So we have dividing both sides by square root of 2. Of course, this will cancel. What is left is L is equal to 14 square root of 2. And of course, it is not so beautiful to look at, so we need to rationalize. So we can have the leg or the length of the leg is equal to 14 square root of 2 times square root of 2 over square root of 2. That is rationalization. And of course, that will be equal to 14 square root of 2 over square root of 4. And we know that square root of 4 is equal to 2. So, 14 divided by square root of 4, which is 2, is 7. So, we have the length of the leg is 7 square root of 2. Therefore, the length of the leg is 7 square root of 2. That's it. Problem number 4. A tower casts a shadow of 32 meters. At the same time, a 5-meter post casts a shadow of 8 meters. How high is the tower? So this is a real-life application of the similarity of triangles. We start with this given. A tower casts a shadow of 32 meters. So just imagine that this is a tower, because I'm not good at drawing. This is the tower and it casts a shadow. So just again imagine that this is a shadow and the length of the shadow is 32 meters. And then moving on, at the same time, a 5-meter post casts a shadow of 8 meters. Again, just imagine this is a post which has a height of 5 meters and the length of the shadow is 8 meters. Now, in the problem, it is emphasized that this situation is happening at the same time. And then what is asked is how high is the tower? So if you are just going to look at our figure, it does not make sense how we can solve this with this figure. So one phrase that can help us is this one, at the same time. So what does it mean? When we have the shadows and then it happened at the same time, it means that there is an imaginary line from the end of the shadow towards the sun, or towards at the end of the tower and the post. And this angle, we call this angle of elevation. Since it is happening at the same time, it means that these two angles are congruent because the shadows are taken at the same time. And then anything that is standing or vertical, it is always perpendicular towards the ground. So in geometry, we always assume that. That's why we can say that this angle is always congruent to this angle. So now we have two triangles, triangle ABC and triangle DEF. So I just named the two triangles so that it will be more convenient for us to have pairings. Angle B is congruent to angle E because they are both right angles, and angle C is congruent to angle F. As I explained earlier, they have the same angle of elevation because it happened at the same time, the taking of shadow. Now, one of the similarity theorems being discussed in your module is the AACB theorem. Two triangles are similar if two angles of one triangle, so that is angle B and angle angle B and angle C, are congruent to two angles of another triangle. Angle B is congruent to angle E, angle C is congruent to angle F. So we are meeting the requirements of this similarity theorem. So we can say that triangle ABC, this triangle, is similar. We use the symbol for similar. Triangle DEF. So it is very important to emphasize this one. When the two triangles are similar or any two polygons are similar, it will follow that their corresponding sides are proportional, meaning if we are going to make a ratio of their corresponding side, for example, AB, that is corresponding to DE. So if we make a ratio AB over DE, that should be equal to, because they are proportional, BC over each corresponding side, which is EF. So we have AB is over DE is equal to BC over EF. This is the implication when we say triangle ABC is similar to DEF, or this is the result that will be very useful when we establish that these two triangles are similar. So substituting the available values, we can have AB is what we are looking for. So meaning we can substitute that with any variable, example x, because that is what is common. X is always present, and then DE, this side is equal to 5, BC is equal to 32, and EF is equal to 8. Now, applying the first lesson in your modules right now, we can apply cross multiplication. So we cross multiply 8 times x, the product of 8 and x, as well as the product of 5 and 32. So we have 32 times 5, or 5 times 32. And solving further, we have 32 times 5 is 160. Dividing both sides by 8, we can have 8x divided by 8 is equal to x. 160 divided by 8 is equal to 20. Therefore, the height of the tower, which is what we are looking for, is equal to 20 meters. That's it. Problem number 5, and the last problem in this video tutorial. A rectangular field is 25 meters wide by 50 meters long. How long is the diagonal path connecting the two opposite corners of the field? Again, to have a better understanding of this problem, you need to illustrate if an illustration is not available. So we start with a rectangular field. So we draw a rectangle 25 meters wide by 50 meters long. So this width is 25 meters, the length is 50 meters, and that is a rectangle. The question is, how long is the diagonal path connecting the two opposite corners of the field? So again, if we have two corners, we can connect. And what is asked in the problem is, how long is this diagonal path? So now, going back to the definition of a rectangle, when we have a rectangle, it means that all the four right angles are congruent, meaning if we consider this triangle, this angle is a right triangle. So that we will not be confused, we name our vertices. This vertex is vertex V. So basically, if this vertex V, this side opposite vertex B, V is side V. If this is angle I, the hypotenuse opposite the right angle, we name that as I. And then for this vertex A, so we name this side as A. Now, if you observe, we have a triangle, right triangle VIA, and it is not a special triangle because it is not stated, and we cannot derive any properties that will show it is a special right triangle, but we know it's a right triangle. So in that case, we can still apply the Pythagorean theorem. By Pythagorean theorem, it says that the square of the length of the hypotenuse is equal to the square of the length of the two sides. So since this is the hypotenuse, the length of this, which is denoted by I, the square of that, so that is I squared, is equal to the sum of the squares. So we add the squares of A squared and B squared. Using what is given, of course, if this is I squared, if we want to solve for I, we take the square root of both sides. So what will happen? We have I equals the square root of A squared plus B squared. So we have I equals the square root of 25 squared because A is equal to 25, V is equal to 50. So we will have I is equal to the square root of 625 plus 2,500. And then just add 625 and 25, that is equal to 3,125. And using your calculator, it will give you an answer of 55.9. That's very easy. So we have I, or the length of this diagonal path, is 55.9 meters. And then for any word problems, always end it with a conclusion to make it more beautiful and to make you more professional. So that's all for this tutorial video. Thank you for watching and continue learning math with passion. Bye bye.